Yeah,
glad to be here.
mic is not.
Am I audible?
Yeah.
Yep. So hi everyone. So glad. No, no. Am I audible now? Yeah. Thank you. Hey, hi everyone. Good afternoon. So glad to be here. Uh, Today I'm gonna talk about one of our interesting scaling story which we had recently for our Rummy game engine, and that has been a game changer for us. So I'm gonna talk about. But before that, let me introduce myself. So myself, Sandeep, I am currently working in the games as a senior EM. I would like Kunal, you also
Hi,
talk
I am
about.
Kunal Kumar. So I work as a senior solutions architect with AWS and helping Sandeep and his team build new architecture, scale existing one, and various other tech side.
Yeah, thanks, Kunal. Yeah, so firstly, let me brief who we are. So I represent Games 24/7. We are one of the pioneer company in India for a real gaming space. And yeah, so we have major two product. One is RummyCircle. Second one is My 11 Circle. Hope everybody would be aware. So RummyCircle is a well-established product for our skill gaming space where player have sort of unparalleled experience, of Rummy via online. Similarly, in a My 11 space, player have a fantasy experience, online fantasy experience. So that has been us. We were founded by Bhavin and Thampi, I think 2006. Since then, we have been doing business in India into a real gaming space. Moving on. Yeah, so next slide onward, what I'm going to talk about mostly our story belong to RummyCircle. So firstly, I would like to establish what kind of a skill we serve to our player. Yep. So around 6,000 K games per day we enable our player to enjoy. Uh, yeah, around 16K games per minute we enabled our player to play per minute in our platform. To enable 16K games per minute in our platform, we consume around 480K Redis IO operation and subsequently 960K database operation per minute. So this has been our scale. Yeah, so I would like to know how many of you already have played the Rummy or already aware of the Rummy. Yeah, so who people who might not be aware, this is a simple card game where I think player have to make a set sequence as soon as possible. So in our platform, what happened whenever player would like to play the Rummy, they come to our app, they click on Play Now, and there is a under the hood our game engine, which is which is creating a bunch of IDs for that player. Let's say those IDs could be our player ID, those IDs could be our table ID. So the moment we have ID generated from the relational world, we make players sit on the table. That table could be empty or that table could be pre-filled. After that, once, so this is a one dependency from the game engine side that we are leveraging. We are creating IDs from the Aurora DB. After the next phase is a game execution phase, where actually our gameplay gets started. Player are able to, enjoy the game now. So all the game works on a Amazon Elastic Cache. The next phase, next. Yeah, after that, as and when our gameplay is progressing, right, we're generating a huge amount of audit data. Now, our game engine keep persisting that audit data into a same database where we have created a IDs. So these are the three critical phases in our gameplay. So what was the challenge? So we had bunch of challenge in this architecture. The first challenge was that we had a
Look there, your
sorry?
back is facing that.
Yeah, we had a shared database The second challenge was that we had noisy neighbor. So our database was well shared with many other teams. So whenever any big event used to come, like let's say IPL, let's say brand campaign, we used to witness high latency due to other service business. Our RummyCircle business also were getting impacted a lot. So this was again one of the pain points. And because our tables were so used, having, I think, TBs of data, so alteration on those tables were always a risky affair. It was taking around, I think, one of the alteration I remember, that took around 1 day entirely, right? So that is again risky affair. So how we were approaching to solve this problem? To solve a noisy neighbor problem, what we did was that instead of common MySQL, can we have an isolated Aurora DB for just Rummy game engine? So this was a thing, but I don't think this solved entire problem. Moving on. Yeah, so we still had couple of problems even after moving our Rummy game engine, on our Aurora database. The first problem was that what we observed was that our Rummy gameplay, around 90% works on an elastic cache. Only 10% works on a database, which I showed earlier that there were two phases for the ID generation and for the gameplay, maintaining a gameplay data. That's where we were leveraging the database. And for even 10%, if any problem happen, our game will not get started. So that was a problem. So what we started thinking was that, can we have more robust, highly available ID generation solutions? So that's where our thought process was going. And our guiding principle was that, why do we need DB actively? Because we were using 10% DB for our use case in the gameplay. And for 10%, our entire game was somewhat halting. We questioned that, why do we need DB actively? Can we use DB passively? The second one was that, how to increase the availability in 4.9 with the help of, new solution. Yeah, so now, so far, we already had problems. We know that we need some sort of solutions. And what we list down was that, what is the expectation from the solution? The first, and before that, the first constraint we knew from our legacy use cases were that, whatever ID we are going to leverage, that has to be numeric, that has to be unique, all variants. So in RummyCircle, we have a lot of variants like pool. You can play Rummy via pool format. You can play Rummy via points format. So we wanted that our ID need to be unique. Due to legacy nature, we wanted our ID need to be sequential and consecutive. And we wanted that we should be able to get out, let's say, millions of ID in one call. So these were our ID constraint. Later on, from the data consistency level, we wanted that whenever this solution will get placed, we don't wanted any alteration on the existing schema. So that should be remain as it is. We didn't wanted no data loss, and whatever the audit data SLA we have committed to our readers, like let's call it BI intelligence, or let's call it REST team, that remain to be adhered. And the last one was a go live. If, let's say, we are going live, there should not be any downtime, and that should be very, very seamless migration. So these were our, expectations from the solutions. Now, what kind of solution we explored while keeping all these goals in our mind? The first solution was, how about Snowflake? So Snowflake was fine. It was giving us a unique ID, but it does not support numeric one. It always supports alphanumeric one. And due to our legacy use cases, we wanted to have some solution which should support the numeric ID generation. The second one was again a relational database. We were thinking relational database were giving a use case where we can generate numeric ID in batch. Those are durable, but when we run a bigger PD, we have seen that they were not giving us a good latencies. So we discarded the relational database due to this. Okay, moving on, Amazon Elastic Cache. So this was already part of our tech stack. So what we thought, why not leverage Elastic Cache? So it was supporting numeric ID expectations. It was giving us a very promising latency, but this was not durable. In case any flip over happen, this might not be suitable for our business. Lastly, we happened to explore Amazon Memory DB, thanks to Kunal and team. It tick off all the expectation we wanted from our expectation and goals slide. It supported numeric ID generation. It supported low latency. It was a durable. So durability was the main goal here. So we found durability here. Yeah, so after that, Kunal, maybe you can take up.
Yeah, thanks, Sandeep. So, I think you guys are clear on the use case, what the team wanted. They wanted high scalability, durability, and low latency. So all the Amazon Dynamo Memory DB is something which ticks all those. So I'm going to take you a bit deeper into how Memory DB works, and where all you think you have heard about, like Elastic also offers you with the open source Redis, and MemoryDB also provides you with that capability, right? Then where should you opt for Elastic where should you opt for MemoryDB? So that there is a differentiator. We'll talk through those. So within AWS database, as Nirav also touched in, we have means a lot of purpose-built databases on relational, on document structure, on NoSQL key value pair. But today we are going to talk about these two databases, which is a caching database using Elastic Cache. It has two flavors, Memcache and Redis OSS, along with Valkeys, and MemoryDB, which again supports Redis OSS. So when you talk about the caching layer, you have to think about like how long do you want to retain your data. If it is an ephemeral kind of storage you need, you go with Elastic Cache for Memcache. Okay, that keeps the data for a shorter period of time, though it doesn't have any failover available to it. And if you want to have a semi-durable and you also want a kind of failover available to you during any downtime that comes in where the primary goes down, you should have the replica taking care of the getting promoted as a primary. You opt for Elastic Cache for Redis. But there is a catch, there is no persistent storage available within Elastic Cache for Redis. So for that, you have MemoryDB, which is a durable system, along with its as equally least latency provider, and also it takes care of failover and multiple other aspects. So this is kind of a visual understanding to make you understand like what is the reason at what different use cases, which one should be a better option for you. The main key differentiator between two is the durability. Rest, most of the support that Elastic Cache provides in form of Redis is available to you in MemoryDB. By durability, I mean it's multi-AZ durability, supporting failover and instant recovery of means there is no data loss. So just some high level detail on what MemoryDB does. It's ultra fast performance, gives you a like microsecond read and microsecond write latencies. It supports Redis OSS compatible, it's durable, it's completely fully managed. You don't have to worry about maintaining the hardware or software setup. The managed Amazon MemoryDB takes care of all those. scalable. You can scale from 500 to 105 terabytes of in-memory storage. And it's secure through different AWS services, like you can have a IAM authentication through ACLs. So what we used to have, like we have an EC2, you have a database, and then you add a cache in front of it, right? What MemoryDB does, you don't have to maintain the cache and the database separately. Instead, a single database takes care of both the cache part and the database part. So ideal for primary databases. So it can act as your primary database. You don't consider it as a purely as a cache. Okay. So as Sandeep also mentioned, the durability is the major factor, and that's how I will show you in few number of slides how the durability thing works. So you have some data going into the primary acknowledges it after writing it to the transactional log and responds back. And the same time, a say asynchronous call goes to different replicas where the data get replicated into the replicas, and this is the way how you maintain the durability and the faster access. Now let's consider the failover scenario. Okay, so suppose your primary has lost. At that time, you have the data available in the transaction log, which is kind of multi-AZ, and that data will be propagated to your is available to one of your all the replicas, and one of your replica can be changed into a primary, and your application doesn't have to worry like which instance to hit. So this is taken care by the switching over of replica to primary. And obviously it provides you with a zero data loss and failover strategy. So other than what Sandeep had, MemoryDB has various other use cases within the gaming industry, like what all different use cases you can go for: session state and history management, where you need a quicker access; leaderboards, where you need again quicker access of data; data stream processing, when you have multiple data coming in into, say, through some event source, and you want to process those data and process it at the same time, it can come at as a very good handy database for you. So that would be from the database on MemoryDB side. I will hand it over back to Sandeep to talk more about execution and implementation.
Yeah, so far we already had problems. We already had a POCs done. We already finalized that how we are going to solve that problem. Now, in this upcoming slide, I'm going to talk about how we implemented whatever the solution we have finalized. So firstly, let me talk about what kind of use case pattern we had. So, we have various games where we need a IDs for various entity, maybe cable ID, maybe game ID, and maybe match ID. So there are a bunch of IDs, right? So we wanted that if I have to or game engine have to ask one ID, that should be, let's say, if that take 1 millisecond. And let's say if I'm asking 1,000 ID, that should also take around millisecond. So we had a two pattern. We can ask one unique ID that is taking let's say millisecond, and we can also ask let's say thousands ID that should also take milliseconds, right? Moving on. So how we conceptualize entire solution was that we thought that how about placing a one dedicated service which can serve previous use case pattern or access pattern. We call it, let's say, candidate, right? So here is a two entity. One is a game engine, one is a candidate, and candidate is one of our service which is backed by a MemoryDB. So if I have to give you example, let's say game engine is asking, hey, my type is a player or my type is a cable. Give me, let's say, 15,000 cable ID to a candidate service. How candidate service would be responding? And that is a really smart way, and that is where all optimization come into the picture. That candidate service would be saying that, hey, let's take a start ID, let's take an end ID. This range is yours. And this is just a millisecond. This is a one IO operation. And think about, previous to that, if we have to generate 15,000 IDs, we were inserting 15,000 DB calls earlier. Now for us, that is a single IO calls. Hence, it was becoming a game changer for us. Sorry. Yeah, but it may look like that our problem was solved, but actually it may not. What if, let's say, this cannonade goes down, or let's say memory DB goes down? So we are dealing with single point of failure here. How we are going to overcome that? So that was a question. I think we were, questioning ourselves that this is a single point of failure. How can we say that this is us solving our problem? That is where we thought smartly. What we thought that, let's assume, so there is some predictive model in our company which they give us a sort of forecast. Let's say for entire day, how many games are going to play. Let's say for today. And similarly, they give a forecast that in this week, how many games players are going to come to our platform and they are going to play, right? So what we thought was, how about pre-computing, asking predictive model that how many IDs I'll be needing for today, and let's pre-compute, right? So that is what eager ID generation. And to give a availability sense, we thought let whatever the game engine pod we have, let them store this entire pre-computation. It could be, let's say, for next 1 hour. It could be, let's say, for next 6 hours. It could be, let's say, next for 1 day or 1 week. So the key point here to note is that if, let's say, pre-computation ID you have for a week, so for that week, if let's say DB goes down for an entire day, your game engine would be immune. So that is a real game changer for us, and I am going to talk about how it is, how we implemented this. So let's assume that this is our game engine pod. As and when our game engine pod is bootstrapping, what we do that, we go to Cannonade, which is backed by MemoryDB. What we ask that, hey, predictive model told me that I need to do a pre-computation of IDs, let's say, for a upcoming week. So it will ask, let's say, give me all the IDs which I might be required, let's say, for the upcoming week. It could be IPL week, it could be brand campaign week. That model already know. So how active ID? So that memory pod would be getting just two value. That is, this is your start value, this is your end value, and between this, all these range, you can leverage for entire week. And to give a more sense, what we thought, we'll be also keeping a one buffer ID, as in when active ID exhausted, buffer ID will take place. And see, whenever any gameplay request is coming now to game engine, it is just fetching ID from the whatever IDs. It could be 10 IDs, it could be more than 10. It is just fetching the IDs from the active ID pointers. We are not making any IO call. We are not going to database. We are not going to even Cannonade. This is just an in-memory lookup, and we are done. So that's how we solved single point of failure. Even though if Cannonade is down for an hour, for a 15 minute, for a 20 minute, our gameplay is immune now. So that was a game changer for us and for our business, right? So till then, what we were able to solve entirely the DB dependency for the ID generation. And I talk about, and me and Kunal talk about how we solve the entire implementation. Now there were one more dependency in the DB, that was audit data. So as and when game is progressing, our game engine keep persisting whatever the audit comes, and believe me, it is a huge data to database, right? So how we are going to solve audit data? In nutshell, how we are going to remove audit data dependency from our game engine now. So what we thought, and we thought was that how about visualizing audit data as a change event. So if let's say you are playing any game and game has just started, so that is the audit data, and that is a change event that there has been a state change for the game from starting to starting. And how about instead of you going, game engine going to every time to database and update there, how about you inform to the world that instead of you doing that job, just inform somewhere and rest assured somebody will do that job for you. So these were the two guiding principles for us. Because this is a broadcast model, so we were exploring couple of solutions. The first solution was how about leveraging S3, right? This was fine, but when we ran bigger load tests, we saw that this was becoming a slow operation. Later on, we moved to AWS Kinesis. This was suitable for our use cases, but we had migration over it. And next, we had a Apache Kafka. This is something we had in-house expertise. This was already part of our, infra ecosystem. So we went with Apache Kafka. So whatever audit data game engine going to inform now onwards would be on Apache Kafka. So this, at simplest term, this was a simplistic architecture that, let's say, game engine is doing, game engine is helping to play all the games and game has started. We keep starting broadcasting all the change event over a Kafka. And there is a one new brand new service we built. We call it gameplay or game audit service, which was consuming from this Kafka, and eventually this was persisting over a database, which we call it Aurora DB, right? So now, again, game engine is sort of immune from the database, even for the audit data. But what if this Kafka goes down? Then possibly we already committed in our expectation and goal slide that we wanted zero data loss, right? What if this Kafka goes down? Probably we would be in a bad state. How we are going to handle that? So that is where we came up a very simplest design that we thought that, hey, instead of publishing over a one Kafka cluster, can we publish the same data more than one Kafka cluster? So that even though it goes down, we would be rest assured that the second Kafka cluster will do the job. It would be having a data, and my service, which is a gameplay audit service, we made this service a bit intelligent that, hey, you need to understand item potency and you need to figure out deduplicacy, right? In case events are coming, from the both Kafka cluster. So this way, we were able to solve again a single point of failure even for the audit data as well. Yeah, so what was the gains? I mean, we removed, so far we removed dependency, DB dependency from the game engine, even for the our ID generation phase and the audit phase. So what was the gain? And gains were game changer for us. The first one was a performance gain. So earlier, I already given one example that if I had to if I have to generate, let's say, 10,000 ID in an hour, so our application used to make a 10,000 DB inserts. That was a way costly for us. Now that was converted just a mere single IO call. So we saw that we had 40% latencies. I mean, our latencies were down by 40% in all the major API. The earlier I talked about that we had 4-9 goals in our expectation and goal slide. So by removing entirely DB dependency, even for the ID generation phase as well as a gateway audit phase, yeah. So we were able to save around 12 to 24 hour yearly downtime. In terms of business, this is a big game changer. And productivity gains. So what happened that whenever there was a scheduled downtime or any alteration activity, most of our team, they used to do a heavy planning, heavy lifting. That was taking around 2 days, and there used to be early 3-4 DB downtime activity or maintenance activity, right? So that was saved, and we computed this was again 10% productivity gains for our most of our team members. Lastly, business gain. Because our latencies were down, we were offering a best-in-class experience to our player, which eventually resulted players were playing more and more game, players were sticky with us, and that's how we saw a major revenue bump as well, just improving the latency and rethinking our game engine. Yeah, future prospects. So this ID generation is a one thing I think every use case, every company and every team need to solve. So we already crack it thanks to MemoryDB. What we are looking further that we also have a tournament variant in our company. So whenever you offer a tournament to the players, you have to generate ID in one go. Let's say 10 lakh IDs in one go. If 10 lakh folks are going to participate for that tournament, so this service is going to be really game changer. So we are going to leverage this in our tournament work. Also, in our company, we are seeding many more card game. It could be poker. There are other games as well. And this same ID generation solution can be leveraged there also. So we are hoping that this would be reusable at the org level. Yep, so this is what we had to offer you. This was our story. Thank you for your time.
Thank you.